So welcome guys to the challenge number 7 of MATLAB series. So today's challenge is we have to draw the Pascal's triangle. So what is Pascal's triangle? This diagram here is Pascal's triangle. As you can see in this diagram, as you can see that there is first and in the first row there is only one, and in the second there is one and one. The third there is one at the ends, but in the middle there is the sum of those above it. And then in the fourth one, this is the same pattern is followed. 1 plus 2 is equal to 3, 2 plus 1 is equal to 3. This is Pascal's triangle and it goes till infinity. Okay, so to do this thing, we got another method which is called NCR method. As we can see, this is a function NCR function whose value is something like this is an NCR function. We can also denote it by this N and R. Okay, so its value is n factorial divided by r factorial and n minus r factorial. Okay, so this gives us the same value as this vector, like this term is the same as this term. Okay, and if we see this 1 plus x to the power n, then when we expand this equation, the coefficient of x also give this same equation if n is equals to 3, if n is equals to 2, sorry. Okay, so we can say that these numbers are nothing but just the coefficient of x in the expression of 1 plus x to the power n. Okay, so by using this definition we will make a function. So without any further delay, let's get into it. Okay, so to make a Pascal's triangle, we will get an argument, let's say n. It will tell us that in the expression that we described earlier, 1 plus x to the power n, this n here is given by the user, and we have to give the coefficient of this n and all those coefficients before it. As you can see, it will form a Pascal's triangle with number of rows is equals to n plus 1. Okay, so to make this function happen, what we can do is very simple. The expression that I derived earlier, that NCR is equals to n factorial divided by r factorial multiplied by n minus r factorial, is used here. Okay, so what we have to do is just simply use this expression into a function, and then our function will look something like this. So this is the name of the function Pascal, this is the input argument n, and we are saying that if n is not equals to 0, then display 1. Okay, so which means that if n is equals to 0, then there is no output here. As you can see that if statement ends directly here, there is no else statement for this if statement. This is something like this. Okay, so also this is also like this. Okay, so there is no else for this statement, so we are only giving an output if n is not equals to 0. Okay, I can also put it like n is greater than 0, because you can't have n negative also. That's also a valid statement. Then we will display 1. Okay, so and here I am describing a vector as 1 already, because we will simply add the values of the coefficients in it and then display it directly. Okay, just like this. As you can see, I have started a loop here with I is equals to 1 to n, which means I want an overall n plus 1 length. And then again a loop started, and this is the expression that I wrote earlier. I have just put it in the MATLAB format, or a format in which MATLAB can understand it, and then ended the loop, and then simply displayed this a vector. Okay, so every time this loop runs, the a vector returns to the original position, and then again it will get modified, and then we will display it again and again. So this process will happen until until this loop ends, and when it will end when I is equals to n, which means the total number of n plus 1 rows are formed. Okay, so let's try this function out. Pascal, let's say 3. So as you can see, this is our Pascal triangle. If I write something like 8, then it's too big for it to complement, but still let's try it out. Okay, so let's try it out again. Okay, so as you can see, this is something like this. If I put something like 12, but if I put something like -2, it will show nothing. If I say 0, then it will show nothing, but if I say 1, it shows something. Okay, so let's say 20. Well, it's too big of a number. Okay, so that's it for this video. I hope you liked.